This is a video lesson for Introduction to Circular Motion. The essential questions for this lesson are, how do we define circular motion, and what is the difference between tangential velocity and angular velocity? So how do we define circular motion? The ladybug is said to be in circular motion because it is moving in a circle around the center of the record. All right, so let's talk about where the bug is moving fastest. So everywhere on the record, it takes the same time to go around the circle. This time is called the period. We use the capital letter T. T for period. So all parts of the record have the same period. So a spot closer to the center of the record, covers less distance than a spot closer to the edge in the same amount of time. So you can see by looking at the arc lengths here, closer to the middle, this is longer, or this is shorter than this arc length here. So it's longer to go this length than to go this length. So on the outside of the record, it's a longer distance in the same period of time to go than it is on the inside of the circle. What we call the tangential speed is greater at the edge than it is closer to the middle. So tangential speed is greater at the edge than closer to the middle because the tangential speed is tangent to the circle. So a ladybug sitting twice as far from the center moves twice as fast as if the bug was sitting in the middle. Okay, so let's look at tangential speed and velocity a little bit more specifically. So we define speed as the distance traveled divided by time. So distance traveled divided by time. So we know that all parts on the record have the same period T. We discussed that a minute ago. So the whole record spins at the same rate. So we know, so the whole record is spinning at the same rate. So this point on the record is moving at the same rate, or travels around the record at the same time So it takes the same amount of time for this part to go around as this part. So the distance traveled in one period is the circumference of the circle, which we define as 2 pi r. So for uniform circular motion, tangential speed is equal to distance divided by time. So v sub t for tangential speed is equal to distance divided by delta t. Our distance here is the circumference of the circle, so that's 2 pi r over t, capital T, which is the period. So the tangential speed to go around on the record is the circumference of the record divided by the period. Okay, so let's take a look now at a different way to measure speed of a rotating object, and that's looking at the angular speed or the angular velocity. So angular speed, or omega, so that's the symbol we use to talk about angular speed, so lowercase Greek letter omega, is the rate at which an object rotates. So all parts of the turntable have the same period T. So we've looked at this before. we know that the whole turntable is rotating at the same in the same time period. So that's rate t. It takes the same time period t. So the angle traveled in one rotation is 2 pi radians. So that's one total rotation in radians. We measure it as 2 pi radians. So for uniform circular motion, we can say that omega, which is the angular speed, is equal to the change of theta divided by the change of time. So this is the change of angle divided by how much time it takes. So one whole rotation is 2 pi divided by the period t. So this is measured in radians per second. So omega is radians per second. So one full rotation is 2 pi over the period t. So that is the angular speed, the speed at which the record is rotating for one rotation. So 2 pi radians over the time period or the period in which it rotates at t. So when we discuss revolutions or we discuss something spinning around, we're going to say that counterclockwise is positive and clockwise is negative. So just like we say that something moving to the right is positive and to the left is negative, something moving counterclockwise is positive and something moving clockwise is negative. And then finally, we can translate angular speed, omega, into tangential velocity by multiplying times the radius. So if we know the angular speed, so what's the angular velocity of something rotating, we multiply that times the position of the object on whatever is rotating, and that gives us the tangential velocity. So for example, if something is sitting here on the record, whatever the angular speed is, so however long it takes to go all the way around the circle, times how far it is away from the center of the circle, that distance r, multiply those two together, and that gives us the tangential velocity.